Good evening, friends. Welcome to Eason Academy. And we are into embedded system programming sessions. And today we are discussing about C programming. And today is session 8. And that you know that it's today's session is going to be the finally critical on C programming as well as in embedded system programming. And it's a quite interesting session also. Please ask your doubts and make sure try to understand. This is the pointers is the best of C. Pointers is the best of C. This helps you to control every hardware. This is a very, very important to understand about how the embedded system program works with pointers. That's all. If you know how to use pointers, you are the person. I'll explain to you in a few minutes. That's it. What is the trick of pointers, which we have already discussed in the C session? Pointer is nothing but an address. Am I right? Pointer is not. See, you have a memory. You have a memory. The memory, you have a address. And you have data. Data is what you write there. In C, we call this as a pointer. And we call this as a variable. That's all. So if you say int x, and this is variable. But what is hidden is and x. That is hidden. It's not shown to you. This is at the pointer, which you cannot change. We have discussed already. You cannot change and x. So don't write program to write and x. Somewhere if you see that and x is equal to 0x1000, this is wrong. You cannot do that. You cannot change the and x. This is a wrong code. In interview everywhere you should say this is wrong, because this is allotted by compiler. You don't have a right to change. The system will not, compiler itself will not allow you to change. That's fine. Now, if I say that int star y, see that int star y, the star y is a variable. But here, what Dennis did was, in the star y is a pointer, which you can change. You cannot change and y, but you can change y. That's why this is called, y is called variable pointer. Because you can change. Since you can change, so y is having a location here. Please understand, when I put star y, here, in star y is a variable. Please understand. When star y is a variable, y is a pointer. But here, you will have y as a variable and y is a pointer. This is fixed pointer, you cannot change. So when you define only x, I allocate only one space in the memory, x, only one space. But if you say int star y, we allocate one space for star y, we allocate another space for y. Okay. For example, we'll discuss later. I'll tell you something called, there are something called int star y. If you do the int star y, it's like this. Star y is a variable. Star y is a pointer. Star y is a variable. Y is a pointer. Y is a variable. And y is a, this is fixed pointer. This is variable. This is pointer. This is a variable. This is a pointer. This is variable. So understand, start y is only variable, and y is a fixed pointer, but y and star y are variable pointers. Don't get confused. I just explained to you that knowing this is will help you along. That's why I just explained. Right now we stop with this. And one more pointer is int a of 10. In this case, a is a pointer. A of 0, a of 1, up to a of 9 is all variable. But of course, this also pointer, and a of 0 and a of b, a of 1 up to and a of 9. So for any variable, if you put a and sign before, that become address. But the only thing is, since I'm putting and, these are all fixed pointer, you cannot change. Allocated by compiler. Only if you say star, you can change. There are some more things like that. We'll discuss these things later. Once you are good at programming, maybe about after a month or two, I'll explain to you the advanced one. There you say that there's something called int star a of 10. This is called array of pointers. And there's one more thing called int star a of 10. Okay, this is pointer to an array. These two are different. These two are different. Don't get confused. We'll discuss those things later. Don't right now. You need to concentrate only on programming. Now I tell you one important thing. If you write a program, char star x and short star y, long star z, it means that in memory, I've allocated a space for star x, which is character, only 1 byte. Then star y, allocated 2 bytes. These 2 bytes are allocated for star y. Long star z, so I allocated 4 bytes. 4 bytes, star y. Understand? The address here is x. The address here is y. The address here is z. But the beauty is, all the addresses are same size. Please understand. 4 bytes. All the addresses are same 4 bytes. And x, and y, and z. Please understand. Oh, sorry. Z, correct. And Z, star Z. Perfect. Yeah. Thanks. Perfect. I shouldn't do this mistake. Okay. So Z star Z. That's fine. So, but see, this is 1 byte because you say character. The variable is 1 byte. You have seen short. Here it's 2 byte. And long, it is 4 byte. But the address of each one is same, 4 bytes. Depends on the processor you have. If it is a different compiler, everything different too, we will assume right now all 32-bit. Don't get confused. Understand now. So pointer is always 4 byte. Now, if I say that x is equal to 1000, that means that I am allocating x to 1000. That is, this is 1000 location. And y to 2000. and Z to 3000. This is correct. I'm given addresses. This is perfectly right. But unfortunately, the C compiler thinks the numbers 1000, 2000, 3000. It takes all of them as integers. It takes all of them as an integer. Understand? It takes all of them as an integer. No, I'm not getting you what you say. Yeah, if I say x is equal to 1000, y is equal to 2000, it's all integer. But x is not integer. Please, x is not integer. Understand? It is a pointer. It's a pointer. Of course, it occupies integer location. Everything is correct. Logically, everything is right. But unfortunately, the C compiler will say that you are trying to equate integer with what? Character pointers. See, left side is a character pointer, right side an integer. Even though character pointer integers are same, both are 4 bytes. Yeah, if you put star, you cannot store, then it become wrong. Okay. If you put x here, x variable, then you cannot store. But x, see, star x is a 1 byte, but whereas x is a 4 byte. X is a pointer. Star x is a variable. Variable I declare 1 byte, but x is an address, which is 4 bytes. That's why I put 1000. If you put char x, x is equal to 1000. This is wrong because x is a character. You cannot store less than minus 128, greater than plus 127. That is wrong. So please. Correct. If you say, that's good. Somebody has asked this question now. Now I'll explain to you this out. So I missed. I say char star x, short star y, long star z. Now I say long star m. Now if I say like that, star long m, the system allocates 8 bytes. 1, 2, 3, 2, 3, 4, 5, 6, 7, 8. 8 bytes. For what? Star m. But m is here. Once again, 4 bytes. M is address. M is address. So, and m. So, x, y, z, and m. These are all address. So, x, y, z, m are only 4 bytes. But star x 1 byte, star y 2 byte, star z 4 byte, star m 8 byte. The problem is this. This 4 byte is for long, as well as the pointer is also 4 byte. So this is correct actually, but the compiler says that you are doing a mistake because the x is not the integer. X is a character pointer and your right side is integer. So what we supposed to write is like this. Char star 1000. See that? When I do here, I put short star 1000, 2000. When I put here, I say long star 3000. When I put m, I say long star 4000. This is very important. This is called typecasting. That means that this is called type. Why I'm telling now is when you're writing program, you will be getting warning. So better you understand that why you have to do this. It will not give error, it will give warning. Please understand the difference between error and warning. Error means mistake. This will not, you cannot even compile. Warning means compiler is telling you that you're doing a mistake. That's it. But generally, companies don't allow. The moment in an interview, if you write like this, a program in an interview, there's a good possibility you get selected. That means that they understand that they will immediately ask you why you are putting the character star. This is an opportunity for you. See, you should make a code such a way that they will ask you the question doubt. The moment they ask you that why you are putting that, you tell them this for typecasting. This is pointer, this is integer, this is pointer. So I'm trying to typecast. That's it. You won the game. These normal embedded programmers do not know this. But I request you to know this to get into the embedded. That's a big difference. So please understand all these things. These are all, see, for example, here, see here, I do a small thing here. This looks to be very simple for you. What are all mistakes you will do in pointer? That's what I'm telling. I say char star x int y. Am I right? If I say int y, this is variable. Y is a variable. And y is a pointer. Am I right? And y is a pointer. So I can say now x is equal to and y. Am I right? Because in the star x is a pointer. Don't get confused, please. It's very, very simple. See, if it is this cutting, there are one, see, in your house, in a street, there is a house. The house number 25 is address. The house Balaji is staying. This is data. Balaji is data, 25 is address. Same thing in the memory. This is address, this is data. In your notebook, you have so many lines. Line 1 to line 6. These are all called line numbers. We call pointer. What you write in the line number 75, 46, 33, 21, 9, 6, these are all called variable. So the line number is called pointer. What you write in the line is called variable. Never get confused. There's nothing great about pointers. There is nothing great about pointers. No, typecasting is not changing anything. Typecasting is not changing anything. I'm telling him that, hey, both are same 4-byte number, but no, this is not converting to 4 byte to 1 byte. See here, when I do that here, when I do here, x is 4 byte here. X is 4 byte. Somebody asked that when I become a typecast, I'll do that. I'll do right now. Char star and y 1000. So we will see that now. Since somebody has asked about practically, it's very good. That's a good idea. Let us get into the board and see the thing. One minute. I'm just sharing the screen. Oh, sorry. Okay, let's set a small program. See that? I write. You'll be surprised. I learned typing during my 11th and 12th in my school. That helped me a lot, like anything. I hope your thing is visible. Okay, now let me compile it. See that? So don't run this because I told you I'm running above software. When I'm compiling it, I'm getting that warning. See that? Warning, assignment to char from int makes. This is a warning. He's not saying that this is an error. But 0 errors and 1 warning. That's a thing you're getting it. You can go and try it at your home also. You get 0 warnings and 0 errors and 1 warning. But the moment I change here, see here. Char star 1000. See that? The moment I put a char star 1000, see, now the 0 errors and 0 warnings. This is called about typecasting. All this, everything is, see, the moment you see any name, they're all pointers. Any name, and main is there. Somebody is calling and main. That you may not know that. Somebody is calling and main. So every symbol is having address. The main is put in a memory somewhere. that says I can write like this. See that? I can write like this. Int star, see that? Star add. Okay. A comma B. Int A comma int B. This is called function pointer. This is called function pointer. When you put star add, this is called function pointer. This function is called function pointer, this add. Okay, this is all you will learn later, not now. Yeah, star x is a variable. I'm putting 20 on the 1000 at 1000. In a memory, wherever, that is what we are using pointer. Please understand. Once again, I'm telling you that why you use the pointer. That's most important things to be understood. There were multiple reasons. One of the main reasons the pointer is, I have a memory. I have a memory here. See, understand thing. My processor, if my processor is having 16 address wires, that means that my processor can address 2 power 16. That is 65,535 locations, lines, 0 to 65,535. That's what the processor can address, not more than that, because it has only 16 wires. So if you write a program, char star x is equal to 1000, star x is equal to 55. What it means, let me write it here, then you will understand. Let me write in different colors, then you will be able to make it. I write char star x is equal to 1000, star x is equal to 55. What it means, that means that this processor is giving 1000 at the address. That means that this is going to point at location 1000. And he is going to give data as 55, which is 8 wires. 55. Convert everything to binary. Convert everything to binary. That doesn't matter. Now this one, 55, goes inside here. And there are 2 more wires called read and write. Since you are writing at that location, write becomes 1. This is what all the microprocessor or CPU. That's in the world. Please, from 1970, 2022, all the microprocessors are doing the same thing. Nothing has changed for last 50 years. From 1970, 2020. Last 50 years, nothing has changed. This is what which is driving the whole system architecture, everything. No, it will not give error. It will give error when you are running it, not in compilation. Compilation, it will give only warning. Maybe you might have set in your compiler settings such a way that if there is a warnings also, yeah, runtime, it will give error, because I told you yesterday itself, understand difference between software and firmware. You are not supposed to initialize a pointer on a computer. That's the reason everybody is worried about pointers. But in firmware, when you're writing on micro, that is what we discussed about bare metal. That is called firmware. That is, your software run directly on microprocessor, then that is called firmware. But you have in between OS, then that is called software. You are not supposed, when you are running above OS, you don't have a control over the memory. The OS takes care of that. So you cannot do that. In that case, you should do like this. I will tell you now. I will tell you how to handle this. You say that char x. When you put x, the system allocates in a symbol table and x, some address. Understand? This is allocated by the compiler, no errors. But when you say here, char star y is equal to 1000. This is wrong. You are not supposed to do it in the computers. You can do it only on the allocating address is acceptable only in firmware, in embedded system programming, not in the computers, please. There, because you are running above either Windows or Linux or Apple OS X, you run above OS. So when you're running anything above OS, you are not supposed to allocate the address like this. This is wrong. Please understand. You will get error. You may get error saying that segmentation fault. The moment you get an error segmentation fault, that means that you mistake the pointer. Your pointers are wrong. That is, your access a wrong location. That is what the meaning for that. That's it. They will say that some errors. Yeah, but you remember the system also, if you use Linux, then it's wrong. But if you use some RTOS, then you can use it. That's possible. Not always, it's not possible. Okay, but if I do here and x, this is acceptable. This is right. This is right. Please understand. Now I say here, see here, I say char x, char star y. I'll show this on the program, this also, demo also. Just look at that, I'll show you a demo. Now, if we put x on the memory, if you put x variable and x is a pointer, when I put star y is a variable and y is a pointer, and y is a variable and y is a address. This is fixed, this is fixed. Now if I do like this, understand, x is equal to star y, and y, y is equal to and x. This and x is allotted by the compiler, which is available. So now what happened? Y become and x. Now this become now and x pointing the location. Now this and this are same. So both are going to point the same location. If you put here star y is equal to 50. Now let us write a program now. Then you will see that. Let me write a small program, then you will understand that what it means. See, I have character star y. Sorry. Char x, char star y. Am I right? Now I say x is equal to 60. Print of percentage d, comma x. So I get 20. I give a small line slash and also one line. So now I put y is equal to and x. X is equal to 50. I change it to 55. Sorry, star y. I don't change x, I put star y. But what I'm going to do now is, I'm going to print the same x, same line, see that. I'm printing the same x here. Both are x is same. I don't change the x, I return x is equal to 60. But now let us run the program. See, 60 and 55. Because this and x is same as this guy's address. So which I'm pointing y. Now the y and the and x are same. So this is now this is pointing same location. This is the advantage of C. You can write anywhere in the memory as you wish. But this is, see, I don't get any error now because I don't validate. But the moment I put the address here, 1000, if I run the program, see here. If you run the program now, I got warning. That is fine. I remove the warning now. See that. Cat star. Typecast. I remove the warning now. I remove the warning now. No warning. But when I execute the program, see, it's hanging. This is wrong. Repeatedly, I'm telling you that this is wrong. Okay, this may give error after some time, some negative values. Okay, so that means that you should never initialize the address with a number in your C program while you're learning. Please understand. But you can, it is possible from next week when you're going to do embedded system programming. I'll teach you how to do that. Yeah, 0 is a thing accepted by the, now I'll see that, now I see here. I write here, understand here. I write here, I just return 70, 67, something. I just return some value. See that now. I run the program. See here what I'm getting now. Process return 77. So whatever I return there, if you don't give a return statement, now I'll show that also. You don't write this return statement. See that. I don't write the return statement. See 0. This automatically the compiler will add a return 0. If you don't include. If you include, that return will come out. See here. 67. You can put any value here. Minus 6, 8. It always return 0. It's minus 8. That depends on the error. If your program gives some error, it returns different values. That depends on your program. Okay. That depends on your programs. How do you write it and everything. So this is used by the operating system, other compiler to show you what error and not. Okay, please understand. So the main advantage of pointer is this. You can change. The main advantage of pointer is you can write in the memory wherever you like. Since we are not going to develop, we are going to work with this one. Okay, So let us do one thing. Let us have a microprocessor, and you are trying to write it to the memory anywhere. This is the one option you are going to use it on the embedded system programming. Please understand. You need to understand. If I tell you write 55 at 2000, read from location 3000. If I tell you this, you should be able to write a program. You know one thing? Let us assume CHAR. You say that CHAR star X, comma star Y. 2. Now X is equal to, now I also have CHAR A. I have one variable, 2 pointer. Now I say that X is equal to 2000. Because I ask you to read from right to X. I put Y is equal to 3000. I ask you to read from 3000. Now I put star X is equal to 55 because I ask you to write 55 to 2000. I'm writing 55 to 2000. Ask you to read from 3000. A is equal to star Y. When I ask you to read, it should be on right side. When I ask you to write, it should be on the left side. Please, I'll give a minute. If you don't understand this, whatever I discuss, I don't mind. This, if you don't understand, let me know. You have to do only this. If you know this too, you will be the wonderful embedded system programmer. That is what we are going to do it from next week. That's as easy as that. You do not have to know anything. If you know these two is sufficient. Do you understand this or not? That's a trick. This is common for people used to ask me that, hey, sir, shall I use microcontroller 8051 or PIC or ARM or Atmega? The only thing is this number changes on each one. That's it. The program is same. Whether putting 2000 or 200 or 100 or 10, that varies between the processor. Nothing else. This program is common. This is for writing. This is for writing. This is for reading. So, if you don't understand, let me know. I'll give about a minute. Just watch this screen once again. If you have any doubt, ask me. Yeah, firmware is very close to the microprocessor that normally we don't update. Whenever it has to be updated, then it's a big process. That firmware can be updated on all electronic devices. That means that the ROM, the code inside the ROM is changed by the app. Now, if you have anything, if it's okay, I mean good, we proceed further. See, the problem is this. There is nothing more than that on the pointers. Understand? But it is made big for you because initially C was used by the software people above the operating system. So you cannot write the code here. So they made this as a big one, pointers. But when you are going to do the electronics in embedded system programming, this is very easy. Nothing. The thing is that when I do this CHAR and X, when I do CHAR star Y, in this case, CHAR X, I cannot change the address. This is where X is going to be written on the memory. Where X is on the memory, where X is written is fixed by compiler. Not you. You cannot change it. You don't have a right. But you can write this location, you can read. You can change to 55. We can change it to 65. If we say X is equal to 55, this will be changed to 55. If you say X is equal to 95, this will be changed. You can do, but you don't have a right on where. But if you do character star Y, you can say Y is equal to 2000 and star Y is equal to 55. You can say where and what. You can change both. In this case, where not possible, what is possible. In this case, where and what. See, why I'm telling this is, normally we have been told in the college everywhere, the big fuss about pointers, which are very confused on everything. There's nothing. It is a very, very easy for us. But you are not supposed to do these things. I see here, once again, I write a program, char star X. Int star Y. Now X is the pointer, Y is the pointer. I say X is equal to char star 1000. Y is equal to X. Am I right? Because X and Y are pointers. So this should be right. But there's a mistake here. The mistake is X is a character pointer. Y is an integer pointer. Even though both are pointers, you should say like this. Int star X. See, don't get confused with this. But when you start writing this, you get errors. One you get errors. Warning. Second, this should be a practice. So you always try to get 0 errors, 0 warnings. These are all the good things for you. You understand C language and today's C language. That's the meaning of this. So when you're writing, writing a program using pointers is very easy. And as I told you that the another main place where you use the pointer is every function. I say I have a function called int check prime. I give a number. This guy returns 0 or 1. Let's say I have a value called R value. Int. It's called R value. Return R value. That's why you put int. Now, what I do here is my process. I find out whether the number is integer prime or not. Prime means R value is equal to 0, not prime. R value is equal to 1. Am I right? Now I return one of them. Your main program say scanf int X, scanf %d and X. You write if is prime, check prime. And X. Sorry, you're passing number. 0 means whatever it is. Else means you'll do that. This is the way you write a program. Why the problem here is you can return only one value in function. Suppose You want to change multiple values. Okay. Let us take a simple case. Let us case a simple case. I have int main. I say char x of 10. I get a string. Scanf %yes and x. And you are typing, for example, 1, 2, 3, 4, 5. But since this is a string, what is stored in a memory will be 48, 49, 50, 51, 52. Suppose you want to convert. You want to convert all these 5 numbers from ASCII to integer. You want to convert from ASCII to integer. Sorry. And X is also correct, but X is the right one. Okay. And X also will not give error, but X is the correct one. Sorry. I did a big, somebody has pointed out very nice. I put X is the address. Let's do that. Now I have a function called convert. And it's not going to return anything void. It's not going to return anything void. Void means I'm not returning anything. I'm getting here char star x. Now you are giving the thing to here. Say I put star y, not to confuse. So you are giving pointer to me. I will check while. Okay. I put while star x is not equal to 0. While star x is equal to 0. Then I'll say that star x is equal to star x minus 48. So now it's 1. So 1 means 49 is saved here. Sorry. 49, 50, 51, 52, 53. These are ASCII values of 1, 2, 3, 4, 5. Now, when I say star x equals star x minus 48, then x plus plus. I increment the x because it's a character, I incrementing by 1. So it goes till it becomes 0 because it's a string. The string becomes 0 here. Now I see here, I'm getting 5 values as an input. I'm doing processing and everything on memory. And I'm not returning anything, but I'm everything goes on a memory, same memory. So I convert everything to now 1, 2, 3, 4, 5. That means that you gave it to my ASCII. I gave it to you back integer. You are subtracting 48. You convert the ASCII to integer. This is all possible if you know the point. Now you understand. This is array. This is string. You are giving the 1, 2, 3, 4. This is the string. You are handling string. And you are passing pointer. Understand? That's why these three are normally work together. Array, string, and pointer. Okay. This is the typical use of pointers. You understand? This is one of the other. This is on programming. I told you 2 uses. One, use it. You are going to write anywhere on the memory. That is what we are going to use it on embedded. Next week, when we take about embedded system programming class, you will really know that how this is useful. You'll be very surprised. This is that's the reason I always say that you learn C and come to the embedded system programming. You will know that. You can start doing very well by next week. Okay. Second one is this. When you are passing the parameters, you pass the address. You pass the thing into the thing, you'll be able to get it. Okay. So there's nothing more to explain. I can keep on explaining pointers more and more, but this pointer is the one thing which you have to practice by lots of writing, a lot of programs. There's nothing more in pointers. Unless you have a doubt, you ask me now. Otherwise, we'll take a break and get into the next session. This is what all about pointer. That is very simple. I have a variable x which has fixed pointer allocated by compiler. Then x is a variable. But when I put star y, then simple. Y is a variable and pointer. Star y is a variable. And in the y is a variable and y is a pointer. So let me show you that in a simple code now. Let me show you the simple code now. Then you'll be able to get to know that. Now I'll do both here. Because certain things, if you see that, you will believe that. Let's say I say x, comma, star y. Okay, I declare 2. Okay. Now what I'm going to do, very simple. I'm going to do printf %d pointer of x is equal to /n and x. So understand now what is that. Now I say the same line. Even though today you may not understand, tomorrow when you see this video, you'll be able to understanding. Your brain, you don't underestimate your brain. Okay, that is too powerful. It remembers everything. See here, now I just run the code. See, no errors. Now I execute. See that there are 2 locations, 642207 and 642232. This is a pointer of x, this is a pointer of y. So even you put star x, the y as the pointer. Understand? That's what I'm trying to say. And y is there. So y is a symbol, star y is a variable. Okay, so when I put star y, when I put star y, here star y is also variable. Y is also variable. That's why you could be able to change. Don't get confused because y is somewhere else. It's another variable. This will help you a lot next classes, coming classes, how this is going to be helpful to you. Okay. So let me stop with that. Yeah, somebody has asked the question this. Let me write this thing here. We put x is equal to 5. Am I right? And I put int x is equal to 5 and int star y is equal to x. Okay. The problem is this y is a variable. It's a variable pointer. Now, what is the meaning of this? Can anybody tell me? If you do like this, what is the meaning of that? If I write like this, int x is equal to 5, int star y is equal to x. I have a memory. In the memory, I have and x, and I have and y, and I have y. And this is star y, this is y, this is x. See, because this x is having and x, which is allocated by the compiler. Now tell me what will happen here? What data, where it will be there? I have so many locations. Now I tell me that somebody has asked this question. Okay. Now what will happen this? This error. Okay. Then let us do that. Anybody else? I want anybody else. Anybody else? Now let us share the screen. Let me type a code. See here, I've typed the same code. Int x is equal to 5. Int star y is equal to x. Printf, first we'll print y. First let me put star y. I put star y because star y is equal to x. Oh, this is error because of this. I don't say that int star, because I'm trying to equate the integer to the pointer. That's a mistake that I told you always. Int star y. Let me see that what's the error later. Okay. Yeah, if you put here, that is correct. If you put and x, that means that you are giving the address. Am I right? If you put like this, okay, then also it will give error. Because both are integer pointer, integer, it's not giving error. Now I run it, it will put 5. That's correct. Because star y is pointing x. But the other one is wrong. If you put like this, then what is the meaning of, I'll tell you now, because before closing, I'll explain this meaning. This alone only people do mistakes. Repeatedly people do mistake. Now if you run the program, it'll hang. It'll hang. Okay. Why? I'll tell you one thing. What is happening now? When you do this, when you write this code like this, when you write like this, now x becomes 5. System allocates and x some address. Now, when you put star y equal to x, this is not, he's not putting 5 into star y. This meaning is like this. Int star y is equal to 10 means y is equal to 10. This is what the meaning of this. Please Don't get confused. See, I write a program like this. See that int star y is equal to 10 means int star y is equal to 10. You are not writing to star y, you are writing it to y. This is the meaning. So I am writing here, the value is 5, not here. So if you write a program like this, int star x, x is equal to 5. Int star y is equal to x. That means that you are not writing it to star x. This is wrong. In C, if you do like this, you are writing into y. Your x is writing into y, not the star y. Please understand that. This is very important to understand in C. Yeah, you are trying to write the location 5. That's why you are getting error. So I think I tried to explain as much as possible in C, pointers in C. But I'll tell once again, you will forget by tomorrow, today even another 1 hour time. This is very, very tricky. You need to practice a lot. You will practice it when you're doing, actually you cannot practice this on a typical software. That we will practice differently. But we will practice it from next week on the embedded system programming a lot. That time you will understand this thoroughly. Okay, then you will know the use of pointers. Let's take a small break.